Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more, and after finishing the courses, I came from for
Good afternoon, dear faculty members. I hope my voice is audible. Okay, we'll start for the day. Shashank sir, you can take over the class.
Sure, ma'am. Thank you so much.
Yeah, thank you.
Okay. So I hope my voice is clear. Yeah. Okay. So we'll start. Let me share. Okay. So before going into the project, so quickly we'll just go through how we can use the AI in finance, particularly using deep learning technologies. Let me just quickly go through some of the things. Right. So these are some of the top use cases, particularly coming into the finance. And when it relates to banking sector or any financial sector, it is more focused about the fraud detection, right, or the risk assessment. So this is in where the finance companies actually focus more on. So it is very important for us. Okay, so our project is also very similar to what exactly the industry assessment actually will be done. So, we are going to discuss about, understand how the fraud will be actually identified using a banking data. Now, so these are some of the aspects you can say, like the customer service, fraud detection, credit risk assessment, wealth management, financial planning, and so on. So many uses are there when it comes to the applications of AI in finance. So next, coming to the fraud detection and the prevention. So how we monitor using the deep learning models, right? How we apply it into the AI technology, and how it's more focused actually on how we are going to identify that particular fraud right? Whether that particular transaction is a fraud or not. Because when a transaction is being done, right? So sometimes even before the transaction is done, the type of transaction is actually verified, right? So that's why we have some platforms like the PayPal and all, which actually tries to check the transaction. Sometimes, if you are not able to, prevent the fraudulent transaction, maybe we can, afterwards at least identify that, and we can make sure we can take a preventive measure. But uh, you know stopping it before it is even happening, that is why we are, we can say, that's how AI comes into the picture, by these deep learning models, that how we can actually stop this transactions, or fraudulent transactions being happening. So next Next is the credit scoring and the risk assessment, and particularly in the social media activities or the utility payments. So this payment area has become little tricky in the in past few years, because doing a credit card transaction, or using a debit card transaction, or maybe doing a online transaction, where it is very difficult, because we are actually using these transactions online, whether it might be a UPI payment, or whether it might be a credit card or a debit card transaction, or through even net banking also. So we are doing transactions in many ways. So there is also a high risk which is actually involved to identify whether that particular transaction is a fraudulent one or not. So that is what more focused on the risk assessment will be. So the algorithmic approach, there, the AI-based algorithms, what we are trying to apply, which are, these are more focused on identifying the, or analyzing the situation and making a decision in a faster way. Because, for a human being to identify the transactions and, identify the risk involved is little difficult. It is easy for a machine to actually identify. So in that way, AI algorithms are actually really helpful in identifying these, fraudulent transactions, or whether it is a genuine transaction or a fraudulent transactions. So using the AI chatbots, or using the personalized information which we can take. So this is where the integration has actually come into the picture when it comes to the finance, sector. So data collection and the pre-processing part, then comes the algorithm selection and development, and then the training the model, then feature engineering. So feature engineering, what is feature engineering? We have already spoken about. Selecting the best features which are contributing to the outcome variable. So next is the deployment into the real world, and then monitoring and maintenance. Next is the money laundering, which is a very important process. That is why usually people do something called as a KYC process. So KYC process helps you to identify the certain customer, whether if you just observe, if you have done a huge amount of transaction from your credit card or a debit card, usually you get call from the bank, right? It's an automated call, asking you to confirm the transaction as well. So this might, many of you have encountered. So why this happens is it's an AI call, right? Person is not checking, because even though there are people who work there, each person cannot check each transaction, and and confirm whether the transaction is a genuine one or not. That's not possible. That is why we have used the AI techniques like the automation, where an automated call will be generated, and the AI robot will actually talk and confirm. So it will ask a simple question, whether have you done this certain amount of transaction on this particular time or a particular date. So if it is yes, press one. If it is no, press two. Yeah, report. Like, you would have received these kinds of calls. So this is an automated call which is made by banks or any finance sector, where you can confirm the transaction amount of or confirm the transactions what you have actually done, because it is extremely important to predict the scenarios and situations. So these are some more applications, which I really wanted to share. Like for example, like the sales forecasting, trading, personalized banking, and also we were talking about the credit cards and loan decisions, and then the automated processes and all those aspects. So next is the customer retention as well. So basically, the banks and the finance companies actually try to use this technique as well to basically identify whether the customer is going to retain or whether the customer is going to close the account or not. So customer, or I can say churn prediction or churn analytics, where this is also a very important AI application when it comes to the banking sector, because every bank actually thrives on the customers' accounts, because it is very important for a bank to run, because it has to they get the money through the money what we are depositing in the bank. So that's how banks actually run, right? They rotate that money, and they do invest in different things and all, and so on. So they give out loans as well. Yeah, many of us might also take. So it is very key that they retain that certain amount of customers, so that they can maintain a certain level of money. So this is extremely key when it comes to the churn prediction for the customers. And then obviously the customer feedbacks and all those things, these are obviously very important, because without these, it is very difficult, um, you know for it might be a finance company, it might be a bank, it might be any place. Customer satisfaction, or customer happiness is very important for any company or organization or a bank to run. So next is the regulatory compliances, where adhering to the regulatory things, because this is where RBI comes into the picture, right? We are not going much into banking and all, but we have to understand how this is relating to what we are actually doing. So there are some regulatory things which will be monitored. In India, we usually RBI monitors this. So this RBI monitors for any fraudulent transactions, or any any risk assessment kind of transactions actually are done by the banks, which is not good for the people as well as the banks. So that kind of compliance will be actually put, or that regulatory things will actually be put on the banks and other financial institutions. So these are again some of the applications, right? So we can just move through. So next is the insurance part. So even the insurance, because we are talking about the banking and finance, because nowadays banks are providing everything, right? Right from the insurance, right from all those aspects, right? So that is also very important for the banks to take care of, or any finance companies to take care of that particular, because the claims should not be a fraudulent claims. So next is the financial forecasting. So basically predicting the markets. That's where in the economics and the statistics part of the econometrics, which is the micro and macroeconomics, comes into the picture, along with the statistical part of econometrics. So this concepts actually suggest, or these concepts actually tell you whether how the market is actually there in the global economy, because there will be several parameters. For example, like the Ukraine-Russia war, right? So because of that, many things have actually gone, many things have actually got impacted, right? I'm not going much into what got impacted and all, but you guys might be knowing, or you might be knowing at least a little about what is this war of Ukraine and Russia. So because of that, many market hits, and many issues might actually been happened. So India was actually we didn't had a much of global crisis or we didn't have much of crisis in our country, so that was fine. But countries like US got affected because they were funding for the Ukraine. So this is all political and all, but this is what also to be kept in mind when we are actually analyzing the global data for trying to predict the market trends and economic indicators and behaviors in the society. So next is the budget optimizations and also improve understanding or planning the cash flows and portfolios and all those aspects. We can go. So yeah, portfolio management, stock market analysis, tax planning, right? So this is what these things are actually happening. So wealth management, experience, investment. I'll just skip this. You can just have to go. So this is also yeah. Now let us go to something which is more related to our project, because this is all till now what we have discussed is more of a I can say more of a conceptual understanding, because that just okay. So more of a conceptual understanding of what is finance and all. So many of you might also be knowing about that. So just a quick glimpse I had. Now coming to our project, so what we are actually doing. So we have a data set which is a credit card data, right? So, or I can say the transactions data, okay, of a bank, not necessarily a credit card. It's actually a credit card data, but it's a bank data at the end of the day. So the data which we have is actually being transformed using the PCA. Okay, so that is the reason I'm just starting instead of discussing the data set first. I'm actually starting with the concept of PCA. Okay. So what is this PCA, which is the principal component analysis? Okay. So why it is very important? Why I have to discuss PCA before going into the project, right? Because our project of credit card fraud transactions is based upon auto encoders, right? So what is an auto encoder and what is the relationship between a PCA and an auto encoder, and why I have to why I had to apply auto encoders technique for this kind of data. What is the impact the PCA actually has on our project. So this is what we'll discuss briefly, and then we will go into the project. So you will have a better understanding of what is going to come and what exactly we are going to do. So next, the first thing to understand is what is PCA. So very simple to understand, PCA is nothing but a dimensionality reduction technique. So dimensionality reduction means reducing the dimensions in the data set. Okay. For example, there are some 20, if there are some 20 variables in the data set, let us assume, only 12, columns or 12 attributes, right? Or 12 variables are contributing at least some 96% of information to the data, right? Or they are representing the data at least some 96%. So actually we set a threshold value of 95%, okay? Because there are different, that is basically the industry benchmark. So basically it is a 95% of threshold what we actually keep. That means our variables, what we are considering, should at least retain 95% of the data, which is very important for us. This is what PCA does. Okay. So in much more simpler terms, we will talk. So a dimensionality reduction. So by that term itself, you would have understood that reducing the dimensions. So what are dimensions? Dimensions are nothing but the variables in the data set. Okay. So now let me go a little deep, right? So, and I'll just explain with, how we calculate. Okay. It's a very simple technique, actually. It's not at all complicated, but the only tricky part in understanding PCA is also, little mathematical knowledge is required when actually we are calculating PCA. So it's a combination of both statistical and mathematical concepts. So I'll simplify it and we will discuss it, okay? Because we are not here to discuss or understand much on PCA, but it is very, very important to understand PCA before applying the auto encoders. So that is the reason I have taken the PCA part as well. So now coming to the what is this? As I told you, it's a dimensionality reduction technique, and there are something called as a principal components. So easy to remember again. Principal components are nothing but the components which are important. That's it. Don't think anything apart from that. So principal components are nothing but the important features in the data. Okay, so orthogonality is a measure in linear algebra where we calculate the redundancy between them. So there is a orthogonality technique which comes in inner product spaces. Okay, so those who are from mathematical background, must have already remembered that concept of orthogonality in the inner product spaces, which is in the linear algebra. So matrices, eigenvalues, eigenvectors, right? Vector spaces, inner product spaces. So it is clearly related to the concept of linear algebra. Now, going to what are the steps which are there? The most important thing is the standardizing the data set. So that we also do in the deep learning or a machine learning data set. So already we know that. So we try to standardize the data using the formulas. So next, we calculate the covariance matrix, and then we come back to the eigenvalues and eigenvectors. Based on the top eigenvalues and eigenvectors, we try to build the principal components. So in a simple way, rather than this theoretical thing, I'll just show you one small formulation. Okay, so everybody would have done this kind of calculation of variance, right? In your research, definitely you would have come across, because all of you are mostly faculty. So at least in research you would have done, if not you're not from a statistical background, at least in the research you would have done. So this is a simple formula to calculate the variance, right? So it is a simple formula, xi minus x bar summation xi minus x bar divided by n. So this is used if we have xi minus mu, right? So if it is xi minus mu, summation xi minus mu whole square divided by n, it is for the population. So mu is nothing but the population mean or population average. And x bar is nothing but the sample average, right? For sample standard deviation or variance, we call it as with small s square. For population, we call it as with sigma. Okay, so this is for calculating the variance. So why I have taken up this pic, you will understand now. So this is how you calculate the variance, right? So many of you either might be knowing, or you can have a quick glance of how we calculate. So I've taken a very simple data set to calculate the variance in the data set. Okay, so you usually calculate the mean value. From there, you take the you subtract from xi minus x bar. X bar is nothing but the mean value. So 3 minus 7, 4 minus 7, 6 minus 7, 7 minus 7. So xi minus x bar, and then you square the term, which is xi minus x bar, and then divided by the sample or the population. So if it is a sample, we divide by the sample. So I think we have 1, 2, 3, 4, 5, 6, 7 samples. So since it's a sample, it is 7 minus 1, which is 6. So 66 by 6 will be your 11. So square root of 11 will be your standard deviation. So 11 is the variance, square root of variance will be your standard deviation. So till here, I think we are fine. So this is how you calculate the standard deviation. This is how you calculate the sample variance. Why again? Sir, why statistics part is coming here? Now, you will understand the next part. For doing PCA, we need the covariance, right? We have spoken about the covariance matrix, right? So I showed you how you calculate the variance for a single data. So this is a formula to calculate covariance. Co means two. So for both x and y variables, you are together calculating the variance. Here you have calculated only for the x value, or you can say one sample. Here we are calculating the covariance for the two samples, or you can say two variables, not samples, two variables. Basically, it is two samples or two variables. So this is for the population and this is for the sample. Now, once we calculate the covariance, then we build a covariance matrix. So covariance matrix contains, if it is for two variables, it will contain a, sorry, it will, if we have three, it is usually containing a 2 by 2 form. Okay, for example, if there are two variables, you will have four, or I can say 2 by 2 matrix. If you are having three variables, you will have a 3 by 3 matrix, which is a 9 variable. So here we calculate the covariance for x and y, right? First of all, we calculate for x and x, y and y, and z and z. And then we have the covariance of x comma y and covariance of y comma x. So there is a a variety in this covariance matrix also. So we do something called as a matrix transformation, or not transformation, sorry, transpose, matrix transpose. So even if you transpose this matrix also, the values will lie the same because the covariance of x and y is the same as covariance of y and x. That is why the matrix is a symmetrical matrix, right? And the diagonal elements will lie at the same place even though you do the transpose. So this is how we build the covariance matrix. So once the covariance matrix is built, we calculate the eigenvectors and the eigenvalues. So this eigenvalues and eigenvectors, what we are considering, that is only the PCA. So that is what I told, it's a pure mathematical, first it starts with a statistical measure, which is the variance. Then it goes into the mathematical. See, it starts with variance and then it goes into the covariance, which is again a statistical measure. Then we are going into the covariance matrix, right? The covariance concept is a statistical concept, but the matrix representation is a mathematical concept. And then we calculate the eigenvectors and eigenvalues. So here you can see that the eigenvectors and eigenvalues of the covariance matrix for the set of data is called as the principal component analysis. So it's a pure mathematical, as I told you, it's a statistical and a mathematical concept. So once we build these PCA, it is easy for us to identify the important attributes in the data. So very simple. See, when we are reducing the variables, or when we are reducing the dimensionality or the attributes in the data set, or the columns in the data set, it is very important that our variables which we are selecting and leaving out, what we are leaving out. For example, as I told 20 variables we have and we are considering only 12. So these 12 variables should at least capture 95% of the useful information or useful things what are there in the data set. Then you can eliminate, if these 12 are able to calculate 97%, let us assume. Yes, it is very good. How much ever percentage they are able to calculate, it is really good. So if the minimum thing which it has to calculate, that we, again, when we are discussing in autoencoders, I'll again discuss. So at least 95%, okay? So it has to capture 95% of the data. Now, that only the same thing what we call in autoencoders as the reconstruction error. So, there is a similarity and all, okay? So it is very, very important for us to, understand this, because when it comes to, finance sector, particularly when it comes to finance sector, PCA and autoencoders are very much used when developing a deep learning project for implementing the AI. So that is why, I have also, thought, a thought came up in my mind to also, explain you about the PCA concept. Many of you might not be aware. So in research, you might be doing factor analysis, but I don't remember, many people, who are my colleagues or something, I've not seen many people implementing the PCA. PCA is a wonderful technique, which is, which captures the important features in the data with, not a lot of fuss. It's a very easy thing, but there is a huge flaw in PCA. So that flaw is actually rectified by the autoencoders. Apart, I don't want to keep the suspense. What is the single flaw in PCA is PCA can only, identify the, or it can capture the important features if the data is linear. That is the only, for example, like, for if the data is linear, we apply the linear regression technique for the continuous variables. The same way, PCA is only capable if the data is linear. Sir, what should we do if the data is non-linear? That is where, my friends, we have the auto encoders. That's where, in deep learning they have developed. But if the data is linear, I would always suggest to use the PCA technique, because PCA is very easy. So, very easy to, just a few lines of code, maybe some 10 to 12 lines of code maximum, right? You can easily extract the important features in the data set. So that's how PCA is extremely simple to implement. So now, as I told you about the linearity and non-linearity. So if there is a non-linear data, then, my friends, you cannot use the PCA, because PCA will give you the wrong results, because it is not capable of identifying the important features for a non-linear data. It is only capable of identifying for the linear data. So now, going into the applications, and you have many applications wherever you can just go through this. And I'm just I'll just take this particular part. Because for implementing a PCA for a deep learning project particularly. So for example, here if we have some 10,000 features, it can be reduced to 100 features. So that is the capability of a principal component analysis, right? So these PCA actually comes under the statistical, but usually you study this PCA in multivariate analysis. So here, this is basically this is for example. So 10,000 features, it can be reduced to 100 features. But very important thing is, minimum it should capture the 95% of the variance. So we call here the we use the word variance in PCA. We call it as reconstruction error in the autoencoders. Both are same. Okay. So when you are doing PCA as and autoencoders both, this doubt comes into your mind. So reconstruction error, what is this reconstruction error? What is, here we are calling it as variance, and here we are calling it as reconstruction error. The way we implement differs, because at the end of the day, what we are applying in autoencoders is the loss function is nothing but our, linear regression function, which is the MSE, right? Mean square error. So we apply the mean square error only, which is the difference between the predicted value and the actual value. So at the end of the day, it's all the same, right? The way it's implemented is different, and because this is for linear and that is for non-linear data, you can also apply autoencoders for the linear data also. It has the capability for both, but PCA doesn't have the capability for both. Yeah, I think this sentence also will help you. So using PCA to transform the original data into a new feature set for training models, capturing the key relationships in the compact form. Okay, so image compression and all we can use. I think this one you can just go through. I'm just skipping this. So challenges, yeah, obviously the first challenge is PCA cannot do the capturing for the non-linear data. So that is the difficult part. That is where we have something called as a kernel PCA. But rather than using kernel PCA, or actually we are called it as both kernel PCA, but usually you will see that this kernel PCA is actually mentioned as autoencoders. We have actually one more also, variational autoencoders also. That is one more method which is also there. So next is, let us go to the autoencoders. Okay, I think we have to make a move a little. Yes. So let us understand about the autoencoders. So autoencoders is very similar. It is actually a neural network, right? So PCA doesn't come under neural networks. PCA is a statistical technique, or you can say it's an unsupervised machine learning algorithm. So, but autoencoder is a proper neural network or a proper deep learning, algorithm. Okay. So there are different types of autoencoders, which are the vanilla autoencoder, sparse denoising, which is for the noise. And then we have the VAE. VAE is very important because VAE is based upon probability, right? And our generative modeling is nothing but the probabilistic concepts, right? So our generative AI, right? Generative AI, all generative models are based upon probability, which are using the VAEs. For example, like the ChatGPT, it's a generative model. So they use the probability techniques of imposing, probabilistic latent space, right? Using the normal distribution. So those all use the VAEs. Okay. So now you can see in the modern world, mostly the for text usually we use which is using the probabilistic nature, because all the text data is based upon the probability, so that you can use the VAEs, and we use the CAEs for the image data. Okay, so this one I'm skipping. Yes. So next, anyway, I'll share the PPT. You can just go through as well. So next is, understanding the relationship between the autoencoders and the PCA. So as I told you, autoencoders and PCA are both of the same family, right? We are just calling this as machine learning algorithm, that is deep learning algorithm, but both work for, the same cause, right? Two people working for different, same cause, not different cause, same cause. That is the dimensionality reduction. So that's what the PCA and autoencoders actually work for. So linearity and non-linearity, as I already told you. And the most important thing is the loss function. So, here it is very important that usually we use the, orthogonality concepts when it comes to PCA. And we use the reconstruction error, the same thing what we call, we can also call that in PCA as well. And then we have the flexibility in the eigenvalues and the eigenvectors as well. So autoencoders, it is mostly dependent upon the neural networks. So here there is no such thing called as an eigenvectors and eigenvalues. So we are not using any mathematical formulations. Okay. So next, how to use, when to use. So obviously, how to use is basically, if we are having any, huge amount of data. For example, here I have taken one example where you have any noisy images. So this MNIST is one of the famous data sets which has images. So, if there are any noises and all, you can use to reduce the, because usually, see, please understand, one thing. Why we try to reduce the dimensions? Simple, not much. So just think straight. Why we use dimensionality reduction? When the model doesn't perform well, that's where we use, because that means a particularly overfitting problem. Why? Because if we are finding an overfitting problem, which is the training data performing well and testing data not performing well, if this is the problem, that means the training data is actually capturing more noise in the data, right? So that is in where, that means some additional features which are not required are being captured by the model. That is in where, my friend, this PCA and autoencoders come into the picture, because that is in where these two big boys take care, or they come into the picture, because there are additional features which are not required for the analysis are captured. That additional things which are not required are eliminated because they are not important. The important ones are kept by the autoencoders and the PCA. That is in where these are useful. In reality, almost every data will have overfitting problem. Every data will have the overfitting problem, because but just by looking at the data, you cannot predict that this column or this attribute is important, that is not important, this is not important. You cannot decide on your own, right? Maybe some one or two attributes you can decide, right? Some you might know, you might not know, because it might have some useful information that isn't there. When we plot the graph after building the model, we can see that how much of training accuracy and the validation accuracy is coming on, and how this gap actually is there. And when we plot it even more clearly, we can see that whether the data is overfitting or underfitting. Then we can apply the PCA and autoencoders to reduce the dimensions in the data set. So that is what we are going to do. So now let us go into the data set. So now, since you understood what is a autoencoder and a PCA, it will be little easy for you to understand the project also, because the project is more focused on the autoencoders, which I have taken up for understanding, because particularly for banking and finance, it is autoencoders which is mostly used in real time. So I just wanted to use the similar concept what people are using in the industry. So that is in where I've taken this kind of thing. Right. So any doubts? I'll just give a couple of minutes to. If you have any doubts, you can ask me. We can. I'll share the PPT with you. Okay, the updated one. Yes, yes, Kedar, I'll share that. I know. I'll definitely share. So for the Python code and the explanation part, even for the explanation part, I've prepared one document. I think it will be shared with you. If you already have, fine. So it will be shared with you. Yeah, this PPT which I've updated from the previous one. I've added some slides of PCA and uh, you know autoencoders. That also the updated one I'll share. Yeah, definitely I'll share. So apart from that, anything else to share, which is required material wise and all, I'll share everything. That is not a problem. So apart from that, anything else, like in which platform you're sharing the documents? This one you should ask. Ma'am Shushmita, ma'am, can you clarify on this? You're there. So I think LMS, yeah. Um, I don't think none is there. So I think it is shared in the LMS portal, which has been shown to you on the day one. So I can check with Shushmita or Chandana, I guess. When they're back, I think they'll share the attendance and all. No, you can at that time you can just mention Vidya, Priya. Yeah, so you can mention ma'am. Yeah, you can mention. You can ask. You can just check that. So anything else regarding any concepts or anything, any questions you want to ask, something like that. So if you have anything, please ask fast. We have one project to discuss as well. So yeah. Other than PCA, what are the algorithms will be used? PCA is for them reducing the dimensions one. So why I have to discuss, why I had to discuss PCA is our data set which I have taken is actually it's a credit card transactions which is done. So it's actually a private data set. So and you already know that reducing, or you can say releasing the data, private data, banks data is very difficult. So that's the reason what they have done is they have converted the data. They have converted the data using PCA. So they have converted using PCA. So our data set will be in the form of values will be in the form of PCA. So let me share the data. Just open the data set. Maybe you'll just have one. This data set also, I'll share it with you. It's a huge amount of data. Actually, it is too big, but I just wanted to take that huge kind of data because for the medical, I just went with a simple one. For a credit card, I wanted to take a huge amount of data. I think around some 2 lakh, as far as I remember, it's around some 2,84,000 something rows are there. So it's a huge data set. I'll just tell you which. It's 2,84,807 rows with 31 columns. So yeah, usually you will have like that only for a data sets like lakhs and sometimes even some 50 columns or 100 columns also will be there. So that is where the tricky part comes into the picture. That's where when we analyze the data, it's very difficult to. That is in where the PCA and autoencoders we are using. If we don't reduce the unnecessary columns and all, we are gone. It's very we cannot move forward with the huge amount of data. So let's share the data set. It takes little time to open also. So it's around some 140 MB or something. We'll just share it. Yeah, I think you can see now. So the values which you are seeing in the data set are the eigenvalues. Okay, that is the reason I have actually explained you the concept of PCA. Okay, because the data set which is consisting of total of around 28 columns, and there are totally 31. So the first column is the time. Okay, so this one it is an irrelevant column. We can remove that column, and coming to the amount, this is the amount which has been transaction has been done. Okay, this actually is in this is euros. Actually, the currency is euros. It's a European data set. So you can see some V28, right? So that means there are 28 important variables here there. Okay, the total data set consists of 31 attributes, but there are 28 variables which are there, and then there is an amount, and then there is class. Class is the target variable. In the yesterday's one with that data set, one person, and I remember one person has asked me, how to identify the outcome variable. So here you can identify there is nothing I've written like a target. So here you can identify that the class is given. So here it's a classification problem, right? And here you can see that if you see 0, it is a genuine transaction, or you can say a normal transaction. It's not a fraud transaction. So here they are mentioned in the data set. If it is a genuine transaction or a normal transaction, the class is given as 0. Okay, so if there is a fraudulent transaction, the class is mentioned as 1. So here you can see all are genuine transactions, genuine, right? So somewhere fraudulent transactions will be there. Correct, no? If we search, we will find. Okay. Or we can filter to see. Usually we will have genuine transactions only. Correct, no? Very rarely you will see any fraudulent transaction. That is in where we have to bring in the fraudulent see here. See, here you can see. And finally, I found one in 543 row. Okay, so there is a fraudulent transaction. So I know it is difficult to, because for example, there are some thousands of genuine transactions and one fraudulent transaction. So that's how it actually occurs, right? Because nobody prefers to do any fraudulent transactions that much easily, because it is very difficult. If you get caught or something like that, you can land up in jail or something. So fraudulent transactions are, that's why we're calling it as fraudulent, because it's fraud, right? So we don't have much of fraudulent transactions, but mostly our data will be of genuine. So, this is the tricky part. This is a tricky part. That's why we use the autoencoders in medical data. This is not the case. This is not the case. But when it comes to the finance and when it comes to finance and banking thing, identifying fraud is not a easy thing. It's a very difficult thing. Even the model has to be trained. Even training the model is extremely difficult for these to identify that the transaction which is done is a fraudulent transaction. So yeah, that is one big headache when it comes to the banking. But we cannot simply say it's a headache and we cannot sit, right? So we have to somehow manage and somehow we have to do and identify by building a model whether it is the transaction which is done or which is going to be done is a genuine one or a fraudulent one. And the data you're all seeing is the eigenvalues. It's the eigenvalues. That is the reason I've explained the PCA concept. So all are eigenvalues. So positive, negative eigenvalues can be positive or it can be a negative, anything. Okay. So with this eigenvalues, we will train the machine, right, using the autoencoders. That is what we are actually going to do. Okay. Usually, sir, if there are normal values, then what to do? Usually, we apply PCA, particularly for financial data. Without PCA, we cannot do. So you can just keep that in mind also, that if other kind of data comes, what to do? So each data has its own way of dealing with it, but usually you will do the PCA. That is why I had to explain the concept of PCA also to understand the fraudulent, how to do the fraudulent transactions when it comes to the deep learning in the AI applications. So that is what the thing is about. So any other questions? Maybe I can just give me a break. Yeah. Maybe we can go for a short break and come and then we can discuss the project. So actually this project you will understand very easily because we already have discussed certain parameters, how things actually will be in a deep learning. For example, like normalization of data, right? And applying a model, how to apply the layers, right? And how to plot the graph and which libraries to be imported, what is the use of that libraries which have to be imported, all these things you have some idea. So this project will be a smooth sailing compared to the thing is you have to understand how these autoencoders work and all. That is the only difficult part for you to understand. Apart from that, it is all fine. I hope you'll be easily able to understand. So any questions from your end? Maybe some couple of minutes I can take some questions if you have. Then we can go for a break and come. Oh. Okay, so if you don't have any questions, fine. Maybe if you have in the break time also, you can post it in the group. I'm happy to answer. So we'll just go for a quick break and come. Okay. So nobody has posted any questions. I guess no one has any, I guess. Okay. So let me share the my Python file. Okay. Share. Yeah, I think you can see the fine. I think you're able to see. Fine. So I will discuss this. Now, since the scenario for when we are discussing a data set which has or which is actually used for identifying the fraud transactions. Now, the most or the very important aspect is, first of all, what we are going to do, right? So what we are exactly going to do, we are going to identify the fraud transactions in the credit card, or you can say fraudulent transactions in the credit card data to minimize the financial loss and also improve the customer trust. Because if the bank is not able to minimize the financial loss, or again, sorry, if the bank is not able to minimize the fraudulent transactions, it will impact customer happiness also, or the customer satisfaction also. So it is very important for the banks to do this also, right? Right. So now coming to the the coding part, what we are actually going to do. So here we have the NumPy as NP. So NumPy is basically used for arrays. This we have already seen. Pandas is used for data frames. Matplotlib and Seaborn both are basically used for data visualizations. Then sklearn is used particularly for machine learning tasks. But even though we are doing deep learning is built on the top of machine learning. You cannot, leave machine learning out of the things, right? So here for sklearn, you can see that we are using the pre-processing. So the same pre-processing step we have done for this standard scalar function as well. So next is the model selection, model underscore selection. So in that we have the training and splitting. So this function also we have discussed yesterday. So train underscore test underscore split. Then we have the metrics, which is the precision score, recall, and F1 score. These are very important along with the accuracy. And then for the layers, we are using the input and dense. For building a model, we are using the model function in the Keras. And then for Adam, and Adam is basically used for the optimizers, right? So this is what we are importing. Now loading the data set, right? So this is the address of my computer. You can give your address with the data set. So we'll share the data set to you as well. So now here we are printing the head of the data set, right? So head gives you the first 5 observations in the data set. So yeah. Next comes the checking for the null values. So here we are checking for the null values. So for checking for null values, the simple function is dot is null. Okay, so that is the function in Python. So since our variable name is data, we are giving data dot is null. So is null is basically the function. And if you don't want, to check whether it is yes or no, for example, if you don't give dot some function, it will show for each row, it will show true, 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 and so on. True indicates that there is no null value. Sorry, true indicates it is there is a null value. False indicates there is no null value. So it will give true, false, true, false, true, false. How we will count it? It is very difficult. No. So that is the reason we have one more, small thing attached to that is null function, which is the dot sum function. Dot sum it will only count all, or it will sum the any null values whatever are there. It will only sum and give you, right? We will not have any headache. So our job is to make this simple to understand and to implement, right? So we cannot make, that is why we are using programming, right? To make it more simple. So we have to be very careful that we don't apply things which are complicated. Now here we have applied the dot sum function, and you can see that there is no null value. That is why for every value it has given as some, it has given 0. For every variable it has given as 0 because there is no null value. For example, this V11 has some 2 null values, so it will show 2 because we are using the sum function, no? So it will sum what are the null values which are there, and it will give you the any null values are there in that particular column. So now going down, the most important thing which we also have done in the medical data is the normalizing of the data. So we are applying the standard scalar, right? The method is the standard scalar. To fit the standard scalar, we apply the function fit underscore transform. So fit underscore transform is the function. Now you might get a doubt, sir, already the data has, the data has already been applied using, or it is transformed using the PCA, correct? No? If the PCA is already applied, then what is the need for doing the normalization? Because already the data is transformed, right? So transformed data you cannot normalize. Already that is transformed. See carefully, here we are doing the normalization for the amount column only. We are not doing it for the other columns, which is the V1 to V28. We are not doing it for the variables which are already PCA has been actually applied. So whatever columns PCA has already been applied, we are not changing anything, right? So we are only changing the column which is in the form of amount, because for that PCA has not been done. We can no need of doing for PCA for that particular column. That is the reason they have not done it. But what we will do is we will apply the normalization, which is the standardization, right? And now the next part of the code is that dropping the time column. So time is nothing but the transaction time. So that is not required. Okay. The most important thing is whether the the transaction which is done is a fraudulent one, or it's not a fraudulent one. So it is, we have to identify that. So we don't need that time factor or time element in the data set. So we can drop any columns which we feel it as unnecessary. Okay. So here we are dropping the time column, and here for the amount column we are doing the transformation. Now here we are doing one more small step, which is small but very powerful. What we are exactly doing is we are creating another 2 variables, right? Till now we had the data in the data column, right? We are doing a small task, small but very powerful. What we are doing is we are segregating into another 2 variables, which is the normal underscore data and the fraud underscore data. So what we are exactly trying to do is we are dividing the transactions wherever the class 0 is there, all those put in the normal data, because I told because if there is a class 0, we are having that it is a normal data, right? If it is a class 1, then means it is a fraudulent transaction or a fraud data. So based on that, we are taking that wherever 0 is there in the class column, put into the normal underscore data right, variable, and wherever you see the class as 1, put that in the fraudulent transaction or a fraudulent data. So this is what we are actually exactly trying to do. I will tell you why we are splitting it. It is very important for us to understand that we are splitting to train the normal data first, right? That is the simple thing, because here we don't have enough data. There is a lot of data imbalance when it comes to a fraudulent and a normal transactions. For example, you will not get a data set. For example, here you have 2,84,807 observations. You know, uh, let us think there are 1,000 observations. One small example. So if you take a data with 1,000 observations, how many fraudulent transactions will be there? Maybe 5, 10, not more than that, right? So then you have this much of imbalance in the data, right? So if you have this much of imbalance in the data, how you can train the model? What will happen if you train the model? The model will tend towards the normal data, and it will try to predict that everything is normal, because the model is actually learning. The model is actually learning more from the normal data. So this is very wrong, right? This is very wrong, because a model should be learning correctly all the features. Correct? This is what we have learned till now. So to follow this, it has to train well, first of all, in the normal data, then it can train in the fraudulent transactions, because there is a lot of imbalance in the data. This is a that's why I told it's a small step, but it's a very key step why we are actually implementing it, right? So now coming to the next part is, segregating the normal data, because now see, we are not using the data. We are using the normal data variable here, see. That is why only we have segregated normal data and the fraudulent data. Now, since we segregated it into normal and fraudulent data, we will use the normal data first. So now in this step, we have done in the medical data set or medical analysis also. What we have done, we have dropped the class column in the independent variables, because independent variables should not have, right, class. That is the outcome variable or the target variable. So under the normal underscore data, we are giving that class as the dependent variable. Now the next step is the training and testing the data set. So here we are training, we are dividing into xtrain and xtest. Okay. Now here first what we are trying to do is, we are not taking especially we are not taking the testing date, y train and y test. Okay, first of all, we are training on the x train and x test. I'll tell you why, because we are using this auto encoder. That is the reason I am actually or we have actually taken that. So here train underscore test underscore split, this is already we have discussed this kind of thing. And then we have the testing size as 0.2. So testing size as 0.2 indicates training is 80%. Okay, so training is 80% and testing is 20%. Okay, so this is what we are actually going to implement. Now, the next important thing is building an autoencoder model. So this is the very important as well as the tricky part. Now, first of all, when you are building a autoencoder model, the most important thing which has to be, we have to, I can say, we have to remember, right? The most important thing is, this autoencoder is basically used for detecting the anomalies, right? So that is the reason we actually use the autoencoders, because autoencoders are capable of detecting the abnormal transactions or abnormal activities, right? That is why we are using the concept of reconstruction error. Okay, so little in detail, I will tell you about what is reconstruction error. But this is actually, these are capable of identifying, or these are capable of, defining the fraudulent transactions, which is what we are doing in this particular case. Now, how we are going to implement, this auto encoders. So here we can see that we have given x, I can say x underscore train underscore shape as 1, because we are taking only one, which is the x values. We are not taking the y, so we are only giving as 1. So next comes the dimensions in the data set. So this input layer, what we have mentioned, is the input layer, which is related to the shape of the data. So now coming to the next part, the most important thing is, let me divide here. No, I'll put like this. Wait, let's put a gap here. Yeah. Yes, I'll put like this. Okay, now see, there is a concept of encoder and decoder. You can see here, right? So here we are giving an input layer. Okay, actually the input layer also comes under encoder, but it's okay. For understanding, it is easy to segregate. Okay, so for input layers, we are giving the layers as dense. And you know what is this 14? 14 is the number of neurons, right? Here we can, for example, when we are giving the autoencoders, we can give any size as the neurons. So in the medical data, when we have applied the Keras and TensorFlow, there I told you that we have to give to using the formulation 2 power n, right? But that is not the case when it comes to the autoencoder. Autoencoder implementation is little different from that of the normal method of implementing Keras and TensorFlow. Now here we have something called as encoding. We have something called as an encoding. So we have encoding and decoding. There are two particular aspects. Now, why I am telling this encoding and decoding, there are two things is, this is where the dimensions are actually reduced, right? They are reduced. First of all, see, you can remember encoder like this. Simple terms, yes. So I think everybody knows what is an encoding and decoding, right? That's the same thing which is applied here. Encoding is nothing but compressing the things in the data. So that is in where the features are compressed, right? The features are compressed so that it learns. So the activation function, what we are giving is the ReLU, which is the rectified linear unit. So here we are giving 14 neurons, 7 neurons, 5 neurons, 7 neurons. We have given some neurons for each, layer. Correct? No. Now we are giving an encoder. That means encode the data, right? That means reduce the dimensions. Okay, so that means to compress. Next thing is the decoder. So decoder is nothing but the reconstruction. That is and where we call as the, maybe, I'll just give it like this. Reconstructing back of what is reduced in the encoder. Okay, so I think this should be fine. Yeah, so decoder is nothing but basically reconstructing back of what is reduced in the encoder. Yeah, this line should be fine. Now, one question arises now. So if we are reconstructing it back, right? The biggest problem is the amount of error which will creep in. That we are calling it as reconstruction error. So that has to be minimized, correct? So that is in where for the decoding part, we give different layers, different dimensions, right? Here we have given the activation function as sigmoid, right? So basically what these decoders do is it will decode each layer and it will ensure that the data is, reconstructed back. Okay. This is what will be done. This is the mechanism of an, right? This is what this auto encoders actually does. Okay. Now, coming to the next part, which is the optimizer, which is Adam, and the learning rate is 0.01. So this is standard learning rate, and learning rate is defined with alpha or denoted with alpha. That also I told you. So next is the loss function, which is the, as I already told you, it is, we are not using the cross entropy, because for autoencoders, cross entropy will not work. It works, but it doesn't work well in certain scenarios. So usually what happens is we either go with mean square error or we go with RMSE, which is root mean square error. So this is basically the function which is used to calculate the actual minus the predicted value. Okay. And then we print the summary of the autoencoder. So here we have the layers, whatever are formed. So here we have given the encoder and decoding layers. So here it will start with the amount of inputs it has taken. So it was having some, 29 inputs, where two are missing, 31. Correct. Yes. Why 29? Because out of 31, one time is being dropped and one is the class has been dropped because that doesn't come under the X. So yeah, it becomes 29, correct. And then for the dense layer, it is becoming into 14, right? It is compressed. See here, that is what this table is actually showing. So input is around 29, right? And that become 14 here. It's because it's an encoder. So it has compressed and still it became some more 7, correct? And params is nothing but the parameters. Need not worry much. But this is what you have done here only, it will show. That is even yesterday I told you that, this table is not of much, you cannot do anything with that table. Only thing, sir, then what is this output? What we have to do? That, you can identify that input are 29 and it has compressed or encoded to 14. It has even more, encoded to 7, and it has gone even more further and encoded to 5. So till there, encoding has been done. Now we are doing the decoding part. So decoding part again decoded back to 7, right? See here, it has reduced from the parameters from 420, 105, 40, and then again decoding starts from, so that has been increased again. So 42, 112 and 435. So here even the decoding happens. The 5 has been, again uncompressed to 7, and then it is even more uncompressed to 14, and then it becomes 29 again. This is what this table. So that means you will be knowing that, okay, my layers what I have given are actually doing the autoencoders, and they're actually compressing and uncompressing them. That's it only you can identify. So that is why even in the last tape, medical one also I told that, just make sure whether it is the flow of events are happening or not. Okay, right. So now going to the next part, which is the fitting the autoencoders. Okay, so here we are fitting using the X-train and, okay. So I think I have given it 2 times. Okay. Okay, there's a logical, yeah. Yes, see here, for, if we give 2 times, right, the autoencoder, this is actually, this can be little confusing sometimes. For usually what happens is, for autoencoder, when you are fitting the autoencoder, usually we give as, even for, we give that input again as 2 times. That is what we do to reconstruct it. Okay. So what it means basically is, one for the encoding part, one is for the decoding part. Okay. So we don't give like this for any other kind of deep learning algorithm. So this is the small one. Just for a second, even I was thinking why it has come 2 times. Yeah. Then after thinking for 5-6 seconds, then I realized, yeah, one extrain is for the encoding and one extrain is for the decoding part. So encoding and decoding. That's why there are 2. Okay. Yeah. Even for the validation also, X-test and X-test, one is for the encoding and one for the decoding part. I think you will get a certificate at the end of the thing. I think attendance is a must. Okay. So now here the epochs are nothing but the cycles, right? The amount of training it does, right? So we are giving 50 epochs, and then we are giving the batch size as 32. So batch size is nothing but dividing the entire data into 32 batches. 32 batches is nothing but 32 samples. Okay. So I just put here, wait. Batch size is nothing but the sample size, which is 32. Okay, it's up to you. You can change the batch size. So Shankar sir, ma'am will share the link. Can you just please wait for a few minutes?
Yeah, so dear faculty members, I'm sharing in few minutes. Kindly wait for it. There is some issue. That's the reason it is taking time. Kindly wait for 2 to 3 minutes. I'll be sharing some notes.
Okay. So here you can see the batch size. Batch size is nothing but the sample size in the data set. So the entire data will be actually divided into, it will be divided by 32, which will be divided into equal sample sizes. Okay. Now, coming to the next part, which is the validation and all I have told. And shuffle is nothing but the shuffle in the data set. For example, like, sampling the data set. So using the simple random sampling. Now here, once you run this code, once you fit with the autoencoder, you have some epochs, right? So yesterday when you saw for the medical data, it was taking just milliseconds to run one epoch, right? But here you can see that one epoch approximately has taken me around 7 seconds, 8 seconds, 9 seconds. So you add this 7, 8, 9. For example, like maybe some 8 or 7 to 8 epochs are running in 1 minute. So 50 I've given means around some 7 minutes it has taken to run the epochs, right? So, and I already told you that usually we run around some 500 to 1000. So now you imagine that 500 means into 10. So for 7 times, so 70 minutes. So around 1 hour it will take if you give 500. And right, another 2, which will be 140 minutes. So around 2.5 hours it will take if you give some 1000 epochs. That's what I told. And the data is only 2,84,000. If the data is around some 10 lakh, 15 lakh, 20 lakh, now you imagine, or 50 lakh or 1 crore. Now you imagine, the epochs, the runtime will be more. That also, because I'm using a GPU, right? I'm having I'm running with a dedicated NVIDIA GPU. So if I don't have a graphic card, internal graphics and all, then it takes little more time because the internal graphics GPU is little less compared to that of the dedicated graphic card. So that is in where the compilation of the GPU is very important, or usage of GPU is very important when it comes to the deep learning tasks. So here you can see this is for the training loss function or training loss. So this is the loss function for the training part, and this is the loss function for the validation. Now, if you see, when we started the epoch, the loss function is at 95%, right? Is it good to have a loss percentage of 95%? Absolutely not. That is a horrible way of having a loss function. That means your model is a worthless model, because loss function has to be minimum. What is loss? Loss is nothing but the difference between the actual and the predicted value. If you are having more difference between actual and predicted, that means is your model performing well? No, absolutely not. It is not at all performing well. It is performing very badly, right? So when we started running the epochs, the loss function is more. And if you see, it is drastically coming down. So it became 88, 87, 85, 84. Again, it went up to 85, 85, 85, 85, again 84, 83, 82. Something it went. And even it is this many epochs. So I ran only 50 epochs. Actually, this is actually, I think at least some 500 epochs, can be run. You can, anyway, I'll share the content with you. You can actually run the epochs and you can actually check. So the validation is not that great. Still, more epochs, more training actually is required. Okay. So now, right, when I've passed an unseen data and actually it has predicted wrong. So then, I didn't understood why it was predicting wrong. Now, when I rechecked, now I understood where, because the loss function is very high. This much it should not be, right? So the loss function should be very less, like 0.1, 0.2, very close to 0. It should converge to 0. Right. So now here you can plot the loss function graph, right? Which is using the plot function, which is the matplotlib function. So it will plot the graph and it will show you where the loss function is. Actually, it is around 0.84. No, yeah, here you can see. So I think that's what I'm telling. Around at least 500 epochs are required for this data set. So you will not get a good accuracy. See, that medical data was only 333. That's why even 50 epochs were fine. But since this data set is 284,000, it's not able to capture the things in the data set. That is why the loss function is high. Even my unseen prediction was also wrong. I'll show you that. So that is where this is the best example to identify whether it is very important that we run the model with an appropriate epochs. So that will come with experience doing the projects where we will understand that how many epochs will be, because nobody, as I told you, nobody can that's why we use the early stopping method to identify if the model degrades, the patient's function is used and we are stopping it. Yeah, so all these kinds of magics and gimmicks should be done in order to retain this aspect of to retain this aspect of where the loss function will be very less and the training accuracy will be more. Right. So now going down, next is the predicting the threshold value. And one more important thing is, the most important thing is to reconstruct it back. Not opening the link. Ma'am, can you please check the link is not opening, it seems.
No, it is working. Let me share once again. It is
No, it
working
is
fine.
working actually. I just checked.
Yeah.
Yeah. Working, ma'am. Can you please, Monica, ma'am, please recheck it once. It's working. Okay, so let us go back to the project. So since we have constructed the loss function graph, we can see that the loss function is around some 84%, 85%, which is very bad that I already told you. And now we have to reconstruct it back. So we are trying to predict for the training data, right? And as I told you, the threshold value will be around 95%. Okay. So when we run the threshold value, it will give you that at which value the predictor actually has to identify. Okay. So that is for the the values on the training data set. And the same thing we will actually predict, right, on the testing data set also for the X test, which we have given. So here we have only done with the X train and the X test. See, this is for the X train and this is for the X test. So this is the predicted value minus the original value, okay, or the actual value. Now we go to the fraudulent transactions. Here, ma'am, the attendance link has been shared. Just be online. Patient be. You can see the link. So here we have only, if I go to the top, here we have only done for the normal data because we have taken for the normal data first, right? And now let us go for the fraudulent data. So now here in the fraudulent data, we are dropping the class, right? We are putting into the predicted value. We are, or you can say we are creating another value where we are putting that into a dependent variable. So we are dropping from the independent variable, the class for the fraudulent transactions, and we are putting the class into the dependent variable. And then we are, running the same thing what we have run for the normal data as well. So the same thing we are plotting the graph to identify with the threshold value. Here you can see that the problem here is, yeah, I was telling you the same thing. The fraudulent transactions will be very less. So here, even though we are, putting the, plot, we can see that, okay, this function has been changed. Okay, I have to, okay. Okay, so you can see the fraudulent transactions because the red indicates the fraudulent transactions. Okay, this blue indicates the genuine transactions. So genuine transactions are more, the count is more, and this is the threshold value. Here you can see. Okay, so the problem is with this diagram, you're not able to perfectly see the fraudulent transactions because fraudulent transactions will be very less actually compared to the things. So next is the reconstruction loss. And in the reconstruction loss, while testing it, the most important thing is this part is the threshold value will be checked. See, for example, if it crosses the threshold value, it goes up, it is considered as a fraudulent transactions. Usually, the fraudulent transactions will be considered as an anomalies. That's where the autoencoders are useful. So here, the most important thing is something goes above the threshold value is considered as 1, which is a fraudulent transaction. Something is below that threshold value, which is considered as 0, and it is a genuine transaction. So we can also use the logistic regression to build, but since we are more focused on, because logistic regression is a machine learning algorithm. So for this, predicting the fraud transactions, we can use the logistic regression. It is also a very good measure. Even SVM can be used. So since we are more focusing on the AI applications and deep learning, so that is the reason I have taken the concept of autoencoders. Okay, so actually for a data, right, logistic regression is actually performed first, and SVM is also performed, and then the autoencoders and other models are actually performed, and then we will see whether even the random forest is also a very good measure. So it's an ensemble technique which can be used to for classification. So now, once the training and testing is done, then we take the white train and the white rest to train the model. So now combining both of them and mixing and putting the predicted value. So which is the true value and which is the wrong predicted value. That is what the code is about. So here in this ground truth, where you have the, as we already discussed, 0 is for the normal transaction and 1 is for the fraudulent transaction. So here we have the Y test for the predicted and Y predicted value for the fraudulent transaction. So whether the fraudulent transaction is true or not, and then we are testing the data. Okay, and then we are building the, we are calculating actually. We can also just give the classification report, or we can calculate the precision recall individually for the predicted and the true value. So precision is 0.13, recall is 0.86. Here recall is okay, but precision is very bad. That's why our F1 score is also, the model is not good actually. Why? Because as I told you, the epochs are only 50. So the training is not done properly. That's why the validation, the loss function is around 0.84. I actually strongly request you to run the code with, you can just change the piece of code here. You can just give some 500 epochs or 5,000. Don't give 5,000. It will take a lot of time. Okay. So you can just give some 500 and check whether the, but you have to wait patiently for an hour and a half to run the epochs. You can check whether the data, the validation training loss and the validation loss is actually improving or not. So that one you have to check by giving the epochs as 500, or you can give the epochs as 500, or maybe you can give it as 1,000, and you can actually check. Okay. So yeah, it's been shared. Will be shared again. Please wait. And now coming to the next, after this epochs instruction. Yeah. Now, so now implementing. Okay, it's updated now. Okay, so you can everybody, you can use the link. So it's working. It seems it's fine. Please do it. Just let me complete. Okay. So next is implementing for the unseen data. So for the unseen data also, we are giving the data points, which is used for implementing, which is actually used for implementing the, which is done by using the PCA. Okay. So as this is a dictionary, this is form is a dictionary, right? If you give like this, it's a dictionary. So since we don't take into dictionaries, we can give it as a, or we can convert it into a data frame. So that's what we have done. So for the last project also, we have done the same thing, right? And then for the amount part, we are for the amount part again, we are scaling it back. Okay. So we are scaling it back, and then we are applying, we are converting it to a NumPy array. And then for the predictor, we are applying the autoencoder. So same like what we have done for the medical data. So the same thing, the each step what we have done for the original data set, we have to apply for the the unseen data point also. Then only we can, then only it will be able to predict, because it is trained in such a way, right? It is trained in one kind of way. You have to pass the data also in a similar kind of way, right? So that is where we have to do all this process. So just to check whether the model on unseen data is working correctly or not, we have to pass. Yes, we have to do all those things. That is the tricky part. You can't just pass the data and say, give me the outcome whether it is correct or not. That will not happen. So we have to convert it to an data frame. We have to use the transformations. We have to convert into an array. Then we have to apply that whatever model we have applied there, right? Because you cannot again change the model here, right? We cannot give whatever model we want and expect the output. So that again cannot happen. Okay. So again, after that, we have to give the reconstruction loss, right? And then we have to set the threshold value, and then we have to predict the true label. Yeah, this is what I was telling you about. Reconstruction loss is around 53%. And the prediction, because the model is very bad, what we constructed, it is predicting that it is a normal transaction. Okay, but the true label is 1. It is a fraudulent transaction. That means our accuracy is 0, because our data point is predicting as a normal transaction, but actually it is a fraudulent transaction. So if the model is not built in a correct way also, this kind of abnormality or wrong prediction can happen. So yeah, so this is how you can also remember that training part is extremely important, and also checking whether the data is not underfitting or overfitting. So this part, we have to make sure whether this will happen, so that the prediction doesn't go haywire, or that is the prediction does not work properly, so it works in a fine way. So that's it from my end. Maybe you can come up with any questions if you have. I'm happy to answer your questions. So this is the last day for our FDP. You can just come up with any questions if you have. You can just put it in the chat. Yeah, Chandra ma'am has just shared the attendance also. If whoever has not actually filled the attendance, you can just fill the attendance now. Feedback and attendance, both. Yeah. Some can you suggest some Myra? What is it? My mini, maybe mini projects.
Yeah, maybe actually faculty mentioned in the YouTube.
I think it is mini projects, I guess. Maybe
Yes, yes.
project only. It should be mini as per that sentence framing. So mini projects, you can do these projects as mini projects and major projects. Don't think the healthcare domain and maybe this one, these two are only major projects. You can also implement these in minor projects also. And you can, yesterday one person was also asking that, spam detection, you can apply as one of the projects. Maybe house price predictions. More classification problems actually these days are actually coming up. Like, predicting something which is, going to happen or not, or yes or no scenarios, like in the medical field, like, heart disease, not, using the x-rays, particularly for images. So for images, we are using the CNN models. So by using the images and training whether the person using maybe an x-ray or something like that. So we can also do that. uh, many are there, like predictions on all kind of, I can say, continuous variables, such as the price of something, maybe price of the products, based on the model building and all. So we can do many project as well as a major project on that. So anything else, any question? maybe you can try this automated attendance system also. That is one area which can be done. So I think Chandra, you can take over. I guess no questions.
Yeah.
Maybe.
Okay, Shashank. Thank you so much for this wonderful five-day sessions. Our faculty learned a lot.
Your voice is very low, Chandana.
Now?
Yeah, now it's great. Yeah.
Yeah. Thank you so much for the wonderful sessions.
Thank you, ma'am.
So, dear faculty members, do you have any queries on this? And sharing the attendance link again. Please mark it. And 60% attendance is mandatory for the certificate, and you will receive a certificate within 7 to 10 days. Okay. And any more questions, you can ask me here in the chat box. Yes, Sayed. Like 7 to 10 working days. I have attended 3 days. Will I get certificate? Yeah, Neha. Like 3 days means it will reach 60%. Yeah, you can get it. Okay, we have 2 more minutes. So before 5 o'clock, please let me know if you have any queries, or else we'll wind up this session. Yes, Jamil. Today is the last date. Shashank, you can give your LinkedIn ID in the chat. Actually, like some faculty is asking about future like assistants. In future, if they have any doubts, they can ask you.
Sure. Just give me a minute. I'll share my profile. Let's give me a minute. Get my ID.
Sayed, you have to count that attendance, like you marked on which day. Okay. So like that only you will get to know.
We should be fine.
Thank you, Shisham.
Yeah.
Okay. I hope no more questions. So we will wind up the session. Thank you so much for engaging the session and make it happen.